Now that we know the vocab, we are going to practice today adding and subtracting polynomials. So this whole unit is going to be about polynomials, and it's adding, subtracting, and multiplying. And we will also talk a little bit about how we can do a division also. But the main thing today is adding and subtracting. So the good news is you have done this at the first 6 weeks of school. So we have been doing this a long time. It's just they're a little bit fancier today than what we did at the beginning of the year. So we're going to add polynomials first. This first parentheses is a trinomial. I'm adding to that. This parentheses is another trinomial. So this problem is adding two trinomials together. See the plus sign between them? So that tells me it's an addition problem, not a multiplication problem. So this is going to be combining like terms, all right? So that means I'm not using the reference sheet rules. It is not a multiplication problem. It is not a division problem. And there are no exponents outside the parentheses. So it is not a power situation. So this is just plain old combine like terms. But in order for me to do that, I'm going to need to get rid of parentheses. So I always check, though, inside the parentheses first. I have an x squared, an x, and a 10. Are any of those like terms? Well, no, they're not. You may think the x squareds and the x's can go together, but they can't. X squareds go with x squareds, x's go with x's, and plain numbers go with plain numbers. So these are not like terms. They cannot go together. So how do we get rid of parentheses so that I can do my combining like terms? You get rid of parentheses by doing the distributive property. There is a positive 1 sitting out there in front of that parentheses. So I'm going to distribute that 1 times everything inside the parentheses. And when I get to the end of the parentheses, I'm done. And poof, the parentheses will be gone. So 1 times 5 is still 5. So this is 5x squared. If I multiply 1 times a positive 8, the calculator will still tell me positive 8, and I keep the x with it. So I'm just multiplying the 1 times the 8, and get the calculator will tell me the positive 8, but I just know I keep the x with it. 1 times negative 10 is still negative 10, and there were no x's in that one, so I don't have to worry about it. So 1 times 5x squared is 5x squared. 1 times 8x is still 8x. 1 times negative 10 is still negative 10. So now, though, the parentheses are gone, which is why we do it. So when you can't do what's inside the parentheses, you distribute the number in front of the parentheses to get rid of it. And that distribution is a multiplication process. And 1 times anything is still what you had. So did any of these numbers inside change? No. 5x squared is still 5x squared. 8x is still 8x. Subtract 10 is still subtract 10. So none of those changed, but the parentheses are now gone. So moving to the second set of parentheses. Can you add any of these together? Are they like terms? No, they are not. That's an x to the first power, and that's an x squared. They are not like terms, cannot go together. So how do we get rid of parentheses when you cannot do what's inside? You distribute the number in front of the parentheses. And this is a positive 1. So when I go and multiply positive 1 times negative 12, the calculator tells me it's still negative 12. When I multiply positive 1 times negative 1, because there's a negative 1 sitting right there, so 1 times negative 1 is still negative 1, and I still have the x with it. And 1 times positive 3 is still positive 3, and they still have the x squareds with it. So once again, the parentheses have now disappeared because I did the distribution. Negative 12 is still negative 12. Negative 1x is still negative 1x. Positive 3x squared is still positive 3x squared. So multiplying by positive 1, did it change anything? No. Multiplying by the positive 1 over here, did it change anything? No. But the parentheses are now gone, which lets me combine the like terms. And if you notice, I have x squareds over here, and I have some x squareds over here. So 5x squared plus 3x squared is 8x squared. Don't change my somethings. 5 somethings plus 3 somethings is 8 somethings. Again, do not change that to x to the 4th. They stay x squareds. I am just combining like terms. So now let's do the x to the first power. Here's some there, and here's some more over here. So I have a positive 8x minus 1x. And the calculator, just do the math. 8 minus 1, it tells you positive 7. So put the plus sign down, 7, and then the x stays there. 8 somethings minus 1 somethings is 7 somethings. Again, don't change my somethings. And now I'm down to the constants. Here's a negative 10, and here is a negative 12. Put in the calculator negative 10, subtract 12, and it will tell you negative 22. If you like good guys and bad guys, that was 10 bad guys, and 12 more bad guys came along. How many bad guys do I have altogether? I've got negative 22 bad guys. So now I have 8x squared plus 7x minus 22. Are any of these three pieces like terms? No, they are not. So that is your final answer. That's as far as simplified as you can get. So since there were no equal signs in this thing, we were not solving. We're just simply simplifying these expressions down as far as we can. Specifically, it was an addition problem, and we're just simplifying it down as far as we can. So you got to know when to stop. So here's another problem. Look between the parentheses. We are adding these two polynomials together. There were 4 pieces here and 4 pieces here, so there's not a specific name for them. They're just polynomials. Now, I checked inside, and I cannot do what's inside because this is x to the first power, x to the third, a constant, and x squared. None of those are like terms. So how do I get rid of parentheses when I can't do what's inside? I distribute the number in front of it. If I multiply everything in here by a positive 1, is anything going to change? No, it won't. So I'm just going to pretend that I rewrote them, and I'm just going to get rid of the parentheses. I rewrote them, pretend I did. Now, in my head, I multiplied by that positive 1, but instead of rewriting it, I just got rid of the parentheses because I know nothing is going to change. Second set of parentheses, x to the third, x squared, 10, and 8x. I checked to see, can I do any of these? Are they like terms to be combined together? Nope, they are not like terms. So how do we get rid of the parentheses? We distribute the number sitting in front of it, and that is a positive 1 sitting in front of it. And if I distribute a positive 1 times everything in there, will any of these pieces change? No. So I can rewrite them below it just exactly as they are, or I can just pretend that I did it and rewrote them, and that parentheses is gone, and this parentheses is gone. Okay? So now that sign inside there is still a positive 7x third, plus 9, minus 10, minus 8x. So all those pieces stayed the same, but the parentheses are now gone. So now I can combine all the like terms that are all together here. So I'm looking for the x to the third powers first. I think that's my biggest exponent. So I have x to the thirds there and some x to the thirds here. I have negative 1, because there's a 1 sitting here, negative 1 plus 7. Negative 1 plus 7 in the calculator is a positive 6, and those are x to the thirds. Negative 1 something plus 7 somethings is 6 somethings. Don't change the somethings when you're combining like terms. Okay, so adding and subtracting is combining like terms. Don't change my somethings. That was x cubes. Let's go do x squareds. There's some x squareds, and here's some x squareds. I have negative 9 plus 9. Well, negative 9 plus 9 is 0 x squareds. And 0 times anything is 0. So all I got to do is add a plus 0 down here. Well, if I add 0, is anything going to change? No. So they just really just totally canceled out. So I'm not going to write the plus 0. There's no reason to. But negative 9x squared plus 9x squared canceled out. Let's go look for x's. I have a positive 8x, and I have a negative 8x. So 8 minus 8 is again 0x. So they cancel out. My 8's went away. 8x's went away. I am now down to just the constant. So here's a positive 4, and where's my constant? Over here I have a negative 10. So I've got positive 4 minus 10. Put that in the calculator. Positive 4 subtract 10. And it will tell you negative 6. There are 6 bad guys left alive after 4 of my good guys killed 4 of those. So far I have 6x to the third minus 6. Are either of those like terms? Nope. So that's as far as you go. That is your answer simplified. So know when to stop. Okay, the next 2 examples are subtraction problems. We do them in the same way, but see the minus sign between the 2 parentheses? This is a subtraction problem. So we're not following the reference sheet. We are not doing any of the fancy exponent rules. Okay, we're just combining like terms. But for me to combine like terms, I have to get rid of the parentheses. So I check inside first, though, just in case I could do something inside, because PEMDAS tells me to do parentheses first. X squared, x, and 8. No like terms. I'm checking this one too. X squared, x, and a number. No like terms. So how am I going to get rid of the set of parentheses? I distribute the number in front of it. And what number is in front of it? A positive 1. When I multiply by a positive 1, is anything going to change? Nope. So I'm just going to pretend that I rewrote them, and I got rid of the parentheses. I'm just going to kind of scribble out the parentheses. So how do I get rid of this set of parentheses when I can't do what's inside? You distribute the number in front of it. There's the 1 sitting in front of it, but it is no longer a positive 1 because it's not an addition problem. That's a negative 1 because it's a subtraction problem. So I need to multiply negative 1 times 12 in the calculator. Negative 1 times 12 is a negative 12x squared. Negative 1 times negative 6 is a positive 6, and the x stays with it. Negative 1 times negative 3 is a positive 3. And you can do that math in the calculator. Negative 1 times 12, it'll tell you that. Negative 1 times negative 6, it'll tell you that. Negative 1 times negative 3, it will tell you that. Now, notice, when I multiply by negative 1, the 12x squared became negative. The negative 6x became positive. The negative 3 became positive. Multiplying by negative 1, just changes the signs of everything in the parentheses after it. So all I have to do is rewrite it as a negative, as a positive, and as a positive. So it changed the signs. Now, once I've rewritten them, I'm going to get rid of the subtraction sign and that whole first piece because they no longer exist. It is now negative 12x squared plus 6x plus 3. Now that parentheses are gone, can I combine like terms? Yes. So the only tricky part about subtraction is you need to rewrite the subtraction part because all of these signs changed. So x squareds, I think, are my biggest. So I'm going to have a single line here, and x squareds are here. So that was a positive 9 and negative 12. So 9 minus 12 in the calculator will tell you negative 3. And, of course, we know the x squared stay as they are. X's, here's negative 4, and here's positive 6. So negative 4 plus 6 in the calculator, and it will tell you positive 2. 4 of my bad guys killed 4 of my good guys. It means I have 2 good guys left over. And what's the somethings? They are still x's. And then I have a positive 8 as a constant and a positive 3 as a constant. They go together. They are like terms. 8 plus 3 is positive 11. Negative 3x squared plus 2x plus 11, are any of those like terms? No, they are not. So that is as simplified as it can get. Here's another subtraction problem. So see the subtraction between the two parentheses? So we're going to be combining like terms. All I got to do is get rid of the parentheses using distribution and then combine like terms. What number, and I always checked inside, and this was x to the first, x cubed, a constant, x squared. None of those are like terms, so I just need to distribute to get rid of the parentheses. What's the number in front of the parentheses? That is a positive 1. So when I multiply everything by a positive 1, is anything going to change? Nope, not a single thing is going to change. So those parentheses are gone, and this parentheses is gone. Now this set of parentheses, 8, x to the first, x to the cube. Anything like terms? Nope. So how do we get rid of the parentheses? We distribute that number in front of it. But what number are we distributing this time? It is a negative 1. So when I multiply by a negative 1, this is no longer a positive 8. It is now negative 8. This is no longer a positive 5. It is now negative 5x. This is no longer a negative. It is now positive 3x to the third. So multiplying by a negative 1 changes the signs to the opposite sign. Okay? Positive became negative. Positive became negative. Negative became positive. And now that subtraction sign and that whole first parentheses are gone. This is the new numbers down here, and these were the original numbers on this one because they did not change. So parentheses are gone, combine like terms. X squared, oh no, I want to do x cubes first. So there's an x cube, and here's an x cube. So negative 2 plus 3. In the calculator, negative 2 plus 3 is a positive 1, and x cubes still stay x cubes because we're combining like terms. Here's some x squareds. So there's my negative 7x squared, and I don't have any x squareds over here, so there's nothing to change. These are still negative 7x squareds. Notice I'm doing these in descending order. I'm doing the third powers first, second powers, then the first powers of x, and then I'm putting the constant on the end because mathematicians will write it that way. So let's do x's to the first power. Here is a 1x, and over here I have a negative 5x. So 1x and negative 5x go together. 1 minus 5 in the calculator will tell you negative 4, and my somethings stay the same. And the only thing I have left to do are the constants. There's a positive 8 and a negative 8. Well, 8 minus 8 is 0, so I don't need to add plus 0 out there. So I have x to the third minus 7x squared minus 4x. None of those are like terms, so that's as far as you go. Okay, so there's your subtraction. I have a bunch of these to do on here, so you got 2 addition ones over here and 2 more addition on this side, and then 2 subtraction ones and 2 subtractions. So you're going to pause the video, go work a few problems, check your answers, and then go work a few more, check your answers, just making sure that by the end you have them all right. If you're missing any of them, change your answers to make them right, and then turn it in at the end. The very last problem down here is state the degree of this monomial. That's only a single term, hence it's a monomial. Mono means 1. What is the exponent to the variable? It is a 4, so this is a 4th degree. That's the degree. Find the product. Now, this is a multiplication problem. Okay? There's no plus sign between the 2x and the parentheses, so it's not an addition or subtraction problem. It is multiplication. We've been doing this since the beginning of the year. We always say when we're going to have parentheses and we're simplifying this thing, we look inside parentheses first. Even though it's a multiplication problem, see if you can simplify inside first. X cubed and 5 are not like terms, so you cannot do what's inside. How do we get rid of parentheses? We distribute this piece in front of it to everything inside, and there are 2 terms inside, so I need to distribute it twice. 2x times x to the third. This is multiplication, so we do follow our reference sheet rules. On multiplication problems, we multiply the big numbers. 2 times this 1 sitting here is 2. Multiply the big numbers, the coefficients, and x to the first times x to the third. You add the exponent, so this is x to the fourth. And then 2x times 5, you multiply the big numbers. 2 times 5 is a positive 10. And x times no other x's is still just an x. And then parentheses are done. Can you combine any like terms? They are not like terms, so you stop there. So this is what we'll be doing in a couple of days is multiplication. We just want to remind you that we did this with distribution and with the reference sheet, but we will continue more of this in a couple of days. Right now we're just practicing add, subtract. So make sure you check your answers. And here are the answers. I'll put them over here so you can check them. So in all the ones where it was adding, all I simply did was pretended I distributed that positive 1 because nothing changed, and then just combined my like terms. And again, I was just doing addition, so I just pretended I rewrote them and then combined my like terms. But when we got to the subtraction problems, I rewrote the second ones because when I multiplied by the negative 1, all of these signs changed. So I rewrote them with the new signs, crossed off the old stuff, and then combined my like terms. So I did those on all the subtraction problems. So here are your answers on 1, 3, 5, and I think you can even see 7 down here, 1, 3, 5, and 7. Pause it when you need to. Here are the answers on 2, 4, 6, and 8. And again, pause it when you need to and check your answers as you're working. And then the last ones down here, I think were 9. There's the answer on number 9. And here's the answer on number 10. Okay, we'll do some more tomorrow.